Good afternoon. Hello, my name is Nadhira. So today I would like to present my presentation about my paper. The paper name is Selection Spectral Analysis for Internet of Things or IoT implementation using the model-based IMP and COPRAS method at the Hospital Intensive Care Unit or ICU. The authors of this paper is me, Nadhira, and Muhammad Dahyar. The paper code is 139. So here's the outline. There will be abstract, introduction, methodology, result and discussions, and also a conclusion. Start from the abstract. Internet of Things or IoT as a new trending technology is expected to give solutions to reduce the difficulty of medical staff in ICU by facilitating them to provide more effective and efficient services for patients. The implementations of IoT in ICU require several considerations such as technological capability, security capability, organizational capability, and supporting environment. So the aim of this study helps to give insight to the hospital ICU about the important factors that help ICU to implement IoT-based technology. The study uses two kinds of methods, which are the MATEL, or decision-making, trial and evaluation laboratory-based analytical network process, and COPRAS, or complex proportional assessment. And the results of this research is IoT-based smart inflation monitoring is the first priority technology to be applied in hospital ICUs. So for the introduction, several studies found the level of fatigue in health professionals is high, especially for those who are working in ICU. The level of fatigue in health professionals, which is quite high, can reduce the quality of service and can be risky on patient safety. Internet of Things can be solutions for health services, especially in ICU. In a way, it gets easier to conduct patient monitors, reduce errors, improve communications to be more efficient. The Internet of Things or IoT that can be applied in ICU, such as IoT-based patient health monitoring system, cloud-based respiratory monitoring system, IoT-based for injections monitoring system, and IoT-based technology for tracking hospital equipment. The implementations of IoT require some decision factors that need to be considered by the ICU and the hospital stakeholder prior to the proper implementation. Factors are based on technology, organization, and environment or TOE framework, and including the security dimension. TOE framework covers organizations' influences on the technology adoption and implementation process, as well as the environment context. So, this research conducts three types of questionnaire that will be distributed to doctors, nurses, and IT. And uses two methods, which are the model-based IMP to see visually all the connections among factors that influence the applications of IoT in hospital ICU in Indonesia, and also use COPRAS method to find technology alternative priorities that can be applied. Here are the methodology of the research. The first step is to collect criteria in the literature review, and second step is criteria validation, then distribute questionnaire and calculate the data using the model-based IMP and COPRAS method, and give analysis and conclusions about the findings. So, the result and discussions about the research. First, for the validations of Internet of Things adoption criteria, the initial studies conduct a literature study to determine the criteria for IoT technology adoption based on the TOE framework and including the security dimension, and found that 29 criteria were validated by experts. Here are the 29 criteria. And for the weighting criteria for IoT adoptions in hospital, we use the model-based INP, and the table shows the result of the calculations, and the finding is the weighting of the criteria is based on the second questionnaire on a scale of 0 to 4 and was assessed by 9 experts. The assessment results will then be processed using the model-based INP method to get the visualizations result of the relationship between criteria and dimension, as well as to get the global criteria weights, and found that criterion C29, which is the most or the first priority criteria. And for developed network relation map or NRM, the relationship between criteria and dimension is obtained from the calculations of the total influence matrix or output from the INP for the criteria and dimension on TC and TD matrix. Threshold value for the criteria in dimension 1 is the threshold value for each dimension can be seen in the box, and also for the dimension also there. And the criteria and dimensions value in the total influence matrix that exceeds the threshold indicates that there is an influential relationship of dimension or criteria in the row column. The network relation map is created from the value D plus S and D min S on the total influence matrix or TC and TD matrix. And then we develop the network relation map. The biggest D min S value has a tendency to influence the most dimensions. So here are the visual representations about the relationship among criteria and among dimensions. For the NRM between dimensions, can be seen that environment dimension or D4 has a tendency to influence the most dimension. And for the NRM between criteria and technology dimension, can be seen that reliability criteria or C1 has a tendency to influence the most other criteria, the others criteria. And for the NRM between criteria and security dimensions, fault tolerance or C13 are at the top positions, but do not affect or be influenced by other criteria because its value is less than the threshold. So, availability criteria or C17 has the second biggest D min S value, which indicates the availability criteria or C17 tends to affect other criteria. And also for the NRM between criteria in organization dimension, found that technology resource capability criteria tend to influence other criteria. And NRM criteria in environment dimension found that partner support or C28 criterion tends to influence other criteria. And for the ranking alternatives, the third questionnaires will be filled based on expert subjective assessment of technological alternatives. The data will be processed using COPRAS method to determine the appropriate technology priorities for ICU in adopting IoT technology. One of the stages in COPRAS method is the classifications of benefits and cost criteria. The benefit criteria is the criteria that has bigger value the better. The cost criteria is the criteria that has smaller value the better. So, for the result of COPRAS method calculations found that IoT-based smart inflation monitoring is ranked number 1, which means that the IoT-based smart inflation monitoring is the first priority to be implemented in ICU. And we also did the scenario analysis. We applied 3 kinds of scenario, which are scenario 1 is application crashes because of network traffic, and the weight on the technological and organizational dimension increased by 50%, and second scenario, ransomware virus attacks hospital and environment systems, and the weight on the security dimensions will be increased by 50%. And the scenario 3 or third scenario, government support the implementations of IoT in healthcare, and in fact the weight on the environment dimension increased by 50%. So each scenario influence the weight in the DINP weighting table scores. So the comparisons of COPRAS calculation result after we applied 3 kinds of scenario and found that IoT-based equipment tracking is the first priority in two kinds of scenarios. So, the conclusions of this research is the study results 29 selected criteria in 4 dimensions that benefit to support the decision in hospital ICU. The results of the INP calculations recommend the hospital ICU. The environment dimension is the dimension that most influence other dimensions. The technological dimension is the dimension most likely to be influenced. And another finding is the competitive advantage criterion has the greatest weight. That means this criterion is a top priority. Complex calculations results determine alternative ranking as IoT-based smart infusion pump monitoring with utility level of 100, which means this technology is the first priority in the consideration of IoT technology adoption in the ICU. The final result after several scenarios are applied show that IoT-based equipment tracking technology is a top priority for the adoption of technology in the ICU because this technology tends to be the first priority in the most scenarios. And here are some that I use. And thank you.